Alright folks, welcome back into another case with a Mac surgeon. Today's patient is MacBook Pro A1989. It came in for not charging, but this should be an interesting patient because I already checked few things and then I found out this should be interesting. Let's take a look together and see if we can figure out what's going on with this unit. It's a USB-C controller or it's something different, is not allowing to charge this unit. As always, we do have our checklist, see if it's powering on or not. The unit is turning on. Okay, yeah, you can see the unit is powering on. But the problem is, pay attention on the charging cable, pay attention on the right corner. I'm plugging the charger. I'm getting 20 volt and 0 amp on this port. I'm getting 20 volt and 0 amp on this port. Check it here. Here I'm not getting nothing, 0. Let me plug it I'm getting 0 and nothing. Let me flip it also. Maybe I'm getting 0 nothing, and I'm getting 0 and nothing. Alright, this was something which is telling me it could be both of the USB-C controllers are bad. That's why it's not charging, because these four of them, they have to communicate together in order to start charging by telling each other, okay, I'm good. The other will tell, oh, okay, I'm also good. Then we'll start charging. Either the problem is coming from both USB-C controllers or it's something else. I didn't remove the board yet. Let's open it, the bottom plate, remove the board, and check it together. All right, the bottom plate is out. Next, I have to check the mean PP bus and all other rest of the component. I don't have to go in that route because we know this unit is powering on, which is mean we have a problem. The battery also is okay because on the battery is turning on, but there's something which is related on the right side with the USB-C controllers. But I like to bring in your attention one thing. Let me unplug the battery. All right, now the battery is disabled. Once I disconnect this flex cable from the battery, this cable, that means I don't have to remove this screw because once this cable is disconnected, the battery will disable. That means there's no more power into the motherboard.
Low battery.
And the motherboard, it's safe to touch it or work on it. All right, let's plug it again, the charging cable. Pay attention on the right corner. Now we do have a 5 volt and 248 milliamp, 250, 248, 49. Next port. We have exact same thing, 249, 50, 53, jumping, going up and down. Now check it this side. All right, now we do have a 5 volt, and we have 243, 48, 44, 43, almost close to the same as the left side. Let me check it the other port. And the other port also, it does have exact same readings as the next one and very close to the left side. I think this is something related mainly with the USB-C controller EPROM, the firmware, because the USB-C controller, the chip does have a firmware inside. That's why it's doing a nice job. In order us to figure out if that's really related to the USB-C controller or to the EPROM, I need to remove the motherboard because the USB-C is the EPROM located the other side of the motherboard. So we can check it together. Let me remove the motherboard from the chassis and we can check it together. All right, the motherboard is out. We had an issue on this side. Let's bring it under the microscope and check it, see what's going on here. Okay, we have some source of liquid here. And this is the EPROM, the one which is I was telling. Now let's go into our schematic because this one needs a little bit schematic too. But before I will jump into the board view and schematic, I wanted to check here, see what kind of reading I do have into that damaged component. We have our multimeter in resistance mode. As always, the black probe into any silver area or any screw hole and the red probe the part wherever we wanted to check it. As you can see there's no short. Let me check it. Yeah, this is a cap, it's not shorting. This cap, this is okay. Even if I will connect it now the power, you will see that we are getting some power there too. But let's check a few more things. Not shorting and not shorting. Let's check it also this side. Not shorting, not shorting, also not shorting.
All right, I get it.
By having both USB-C controllers get damaged, it will be for me a little bit strange, because as I can check it, looks clean. If you will try to replace the USB-C port, USB-C controllers, maybe will not fix. Maybe it will fix if it's coming from the USB-C controller. That's why before I will jump it to there, I wanted to go ahead with the board view to show you what I want to do. All right, we have it like this, and these are the USB-C controllers. This is the one. This is the second one. On the part I was talking, it's this one. This is our USB-C controller here. This is our USB-C controller, EPROM, the chip, which is this hub inside a firmware. And then now, as you can see, this power coming from here, and it goes all the way to here. I'm assuming what happened here, because once we start checking, we find that some corrosion in this area, on this part, on this chip here. This is the one, this one, it's exact same thing, this one. I'm assuming because the voltage it dropped, and that it caused to fail our EPROM, this part. But before I'm thinking that could be the reason, I need to check it, see if I do have a communication from that area all the way to there. And then I will check it, see if I do have a power there. Let's do that. I do have multimeter in a resistance mode, or actually I can put in a beep mode. Yeah. And let's check it, see if we have a communication between. Yeah, as you can see, yeah, check it here. I do have a communication between this part all the way to here. We do have a Next, let's check and see if we do have a power over there. Let me plug it. We are going to check this one. Check there with a multimeter. Okay, we have 5 volt by having our multimeter into DC volt mode. A black probe into ground, and here we have a like a 0.1 volt. This is our problem, which is mean this part now either failing or is not giving us full voltage. We don't have a voltage there. All right, let me plug it the other port. I'm checking here now again. We don't have any voltage there. And now it's shorting. Most likely what happened, because I was touching, that component was completely corroded. Once I touch it, it shorted that that component. Let me remove the component and we can check it, see what's happening. Now let's check again. We have our multimeter in a resistance mode, black probe into ground. We don't have any more short here. Our short is done. Now I needed to check, see. At the same time, let me check if we have a communication. Yeah, we do have a communication from here all the way to there. All right, let me plug it again there. Let's check it. And we do not have again any power over there. All right, let me plug this one. Check it. On this side I do have it. Oh, as you can see, even now we have also 20 volt. Let me plug again. Now we do have. Now it's enabled. Okay, the problem was coming from that short. That was an LDO power rail, and that power rail was powering one of the on one side of the USB-C controller, EPROM, the program, which will tell him what to do. It's better to reflow it. All right, and then I need to put the cap over there. Okay, now let's plug it, our cable, and test it, see if we are getting our 3.3 volt over here. Oh, okay, we do have a 20 volt, which is mean we should have also, yeah. And we have our 3.3 volt, pay attention on the right corner. That means this unit now is turning on. Let's round up with this unit. I need to put it into the chassis, the motherboard, and test it. At the same time, I'll tell you so we can understand what exactly happened with this unit. The motherboard is inside the chassis. The battery is not connected yet. Let's check it, see if we are getting our power. It's switching from the 5 volt to 20 volt. Yes or no? Well, I will try on the right side because we do have a problem on the right side. Check it there. We have a 5 volt and 200, and now we have also 20 volt. That means pay attention here, the fans will start spinning. Okay, the unit is booting and we are getting around 20 volt. The lid is closed, so that's why it's not booting. If I will open it, this will start here. It will start it to boot. Let's round up with this case, and also I will try to explain what exactly happened. This was for me like an easy pizza case, but in general, in order to reach in this point to understand from where is coming that issue, I spent, I'll be honest with you, I spent maybe days. Because before, when I had this type of cases, always I was trying to replace both USB-C controllers, and after that was not working, and I couldn't figure out what is the reason is not powering on, because 2 ports are getting 20 volt, the other 2 port is not getting nothing, but 4 of the port, when the battery is not connected, are getting exact same readings, but I wasn't able to find out or understand where is the problem. But now, because I already know, let me also plug the battery so I can show you the unit is charging. All right, the battery is connected. Let's plug this one. It doesn't matter now. All right, we do have our 20 volt. Trackpad is clicking, and as you can see, the battery start charging. We are getting around 2 amp up and down. Yeah, now we start charging properly, 2.8 volt, 2.8 amp. At the same time, we can confirm with our multimeter. You hear the chime of the charging. Pay attention, check it here. See on the voltmeter, now we have like 11 volt, 600 milliamp, and now it's going up 748, 50, so on, and we'll start charging. This case is done. The patient is saved. Data also it's saved, because this unit came in mainly for data recovery, not even for fixing the unit. That's why in the future, if you will have this type of case, like both USB-C controllers are getting 20 volt, but the other 2 are not getting nothing, and it's stuck 0 or it's shutting down, that means most likely you have a problem also with the firmware, or there's a data communication problem, or with the chip, with the actual chip, there's a corrupted firmware. Now, how to fix the firmware? There are so many ways you can fix it. Also, there's a nice tool like this U301, and these tools are designed for that EPROM to program. So you can plug it, put it inside, plug it to your computer, and from your computer you can do the rest. It does have the programmer inside. Also, you can find out what the firmware for this one. If you cannot find the firmware, if you have a donor board, you can take from your donor board, put it inside this programmer, read the EPROM, saving your computer for future in case if you like to use that chip, or so on. There are so many ways you can get it done with this unit. Anyway, that's all for today's patient. The patient saved, the patient is happy, customer will be also happy. I hope you learned something new, and at the same time, I hope you enjoy it. Don't forget to share, subscribe, and comment. In case if you have any question, you can leave it in the comment section, and I will try to answer your question. Bye bye for now, and I'll see you next time.